Hello everyone, in this video let us discuss the chemical reactions of alkenes, that is, the addition reactions. Now alkenes, they contain a triple bond, so they can add up two molecules of dihydrogen or halogens or hydrogen halides, etc. And let us discuss the addition of all these type of the addition of dihydrogen, the addition of halogens, as well as the addition of hydrogen halides and the addition of water in the alkyne molecule. Now first let's check the first type of addition reaction, that is catalytic hydrogenation. Catalytic hydrogenation means addition of dihydrogen. This reaction is also known as Sabatier-Sandurance. This reaction is also known as Sabatier-Sandurance reaction. Now in this type of reaction, the alkynes, they undergo catalytic hydrogenation on heating in the presence of runny nickel. Now in this type of reaction, there is full hydrogenation, means all the these are alkyne, and then hydrogenation in the presence of runny nickel on heating. Now full hydrogenation means two bond breaks up, and then we will be getting here one bond would remain in this part, therefore one bond each would getting, and there would be addition of hydrogen, dihydrogen. There would be full hydrogenation takes place in this type of reaction. Now let's check some of the catalytic hydrogenation reaction. Now when here runny nickel was used as a catalyst in the first catalytic hydrogenation. Now when Lindlar's catalyst is used, let us check the hydrogenation. Now firstly, what is Lindlar's catalyst? Lindlar's catalyst can be lead on CSBD on Ca, CO3, or BaSO4, maybe BB with C3COO2, or maybe it may be quinoline, may be used as a catalyst. Now when Lindlar's catalyst is used, there is formation of cis alkene R, C triple bond carbon R. Now on hydrogenation, when Lindlar's catalyst is used, only one bond breaks up, and then we'd be getting here R. The alkyl groups would be on the same side. Cis alkene is formed when Lindlar's catalyst is used. Now when Birch reduction takes place, this is the same type of reaction that took place in alkanes. So carbon to double bonds, R, C, triple bond C, R. On hydrogenation, Birch reduction is either sodium or lithium in the presence of liquid ammonia. The same reaction takes place as occurred in alkenes. Carbon to carbon double bond, the alkyl groups would be on different side, and then this would be known as transalkene would be formed in this type of addition reaction. Therefore this is the addition of dihydrogens to alkynes. Now the second one is addition of halogens. Now how does the addition of halogens takes place? Let's check the reaction here. Carbon to carbon triple bond, this is an ethane molecule. Now in the presence of CCl4, we'll be getting here carbon to carbon double bond, and then ClH. Now this is known as 1,2-dichloroethene is formed. Now when it undergoes the second halogenation reaction, means with another molecule of chlorine, then we'll be getting all of carbon to carbon, another bond would break up, and then Cl, 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 and then you'll be getting here 1, 1. This is carbon number 1. This is 1, 1, 2, 2. Tetra chloro ethane would be formed. That means all the 2 bonds would break up, and then there would be addition of 4 chlorine atoms to the ethene molecule, thus giving the product. And in the case of a single bond, that is, we'll be getting here an ethane molecule. Now for this type of reaction is known as the addition of halogens. Not here chlorine was added. What happens when bromination takes place in ethyne? Now in bromination reaction, now we know that bromine has a reddish, or like say reddish orange color, or a brownish color of is the bromine have a reddish brown or orange colored solution, orange colored. Therefore now it is seen that alkynes decolorized, means alkynes decolorized the bromine water. Therefore the bromine water is used as a laboratory reagent to identify or to check the presence of alkynes in a mixture of hydrocarbons. Now if the first reaction, bromine water, Br2 water, that means this is aqueous with water. This is not a pure solution with water, bromine water. Now, or Br2 in CCl4, it forms dibromo. Only 1 bond breaks up, and then 2 bromine molecule, dibromo derivative is obtained. But when liquid bromine is used, it gives liquid bromine, means this is our pure bromine, while liquid bromine gives tetrabromo derivative. Therefore it can be seen that in the first case, when bromine water was used, only 1 bond in the alkyne molecule was only 1 bond breaks up. But when pure bromine water, liquid bromine is used, it gives tetrabromo, means 2 bond breaks up, and it gives a tetrabromo derivative. Now if we check here, now this is our CH triple bond CH, this is our ethene molecule. Sorry, this is our ethyne molecule. Now when it reacts with, first let us check with when it reacts with, what happens when it reacts with pure bromine water and then in liquid bromine. Now when it reacts with liquid bromine, only one bond breaks up, and then we'd be getting here 1 HBr. Now only 1 bond breaks up, and we'd be getting a dibromo derivative. But when liquid bromine is used, that is the pure bromine is used, we'd be getting a tetrabromo derivative, and then an ethane would be formed in this case, and ethene was formed, whereas here we had ethane in the form of tetrabromo derivative was obtained here. Therefore in this process we can see that alkynes decolorizes the bromine water. Therefore liquid bromine water is also used as a laboratory reagent to check the presence of alkynes in a mixture of hydrocarbons. Now let's check the third addition reaction of alkynes, that is the addition of hydrogen halides, or also known as means hydrogen, and halogenation. Hydrohalogenation reaction means addition of hydrogen halides. Now when alkynes, this is our alkyne, carbon to carbon triple bond H. This is an alkyne when it reacts with hydrogen halides. Now if this bond breaks and goes up here, the H plus would come and attack here, and then the I would attack the second carbon. Therefore we would be getting here H carbon to carbon double bond, one bond breaks up, and then H I would be here, and then H would be here along with the release. Now there is a formation of, and it double bonded carbon to carbon bonds. Alkenes are formed in this when we do the first addition of hydrogen halides. Now when the second hydrogen halide is added, it will react with carbon to carbon single bond is formed, and we would be getting here geminal dihalides. Means the halogen atoms are on the same side, are on the same carbon atoms. Means the two halogen atoms, the iodine are on the same carbon atoms. Geminal dihalides are formed. Therefore, one important point to be kept in mind when hydrohalogenation or addition of hydrogen halide takes place in carbon to carbon triple bond, geminal dihalides are formed, where geminal dihalides means the halogen atoms are bonded on the same carbon atoms. Therefore, this is the major point of difference in the hydrohalogenation of alkynes. Now, the last type of addition reaction is addition of water or hydration reaction. Hydration means addition of water. Now, hydration reaction of alkynes takes place the addition of water H2O. This is our negative part, this is our positive part, takes place in the presence of 40% concentrated sulfuric acid and 1% mercury sulfate. We'd be getting here the first product that we get here when it reacts, we'd be getting here first an alcohol would be formed here, CH double bond CH2, and then our OH would join here. If this goes up, this would attack here, this would come here. Therefore, in this way, an alcohol is formed. Now, this further, it undergoes tautomerism. It undergoes tautomerism to give here aldehydes are formed. Therefore, when hydration reaction of alkynes takes place, the alkynes, they first react with water in the presence of 40% concentrated sulfuric acid and 1% mercury sulfate to give an alcohol, and then it further undergoes tautomerization reaction to give an aldehyde. Therefore, this are the addition reactions of alkynes. Now let's check. The first one was for symmetrical alkynes, hydration of alkynes. Now if there is an unsymmetrical alkynes, now it's CH3 CH2 carbon to carbon triple bond and then CH3. Now if it undergoes hydration in the presence of sulfuric acid and mercury sulfate, 40% and then 1%, then what would be the reaction? The OH minus can come and add up to this carbon atom or this carbon. Now if the first case, if it adds up to this carbon atom, then 1, 2, 3, 4 and 5. If it adds up to the third carbon atom, then we'd be getting CH2 C OH carbon to carbon single bond. The H would come and attach here, therefore we'd be getting H and then CH3. Now if the second case, if this OH minus come and attaches to the second carbon atom, and then the H plus attaches to the third carbon atom, then we'd be getting here CH3 CH2 CH COH and then CH3. Now we would be confused as to know which would be the product formed in this case. Therefore, one short trick method for the identification of the final product is to check the OH group. Now in this product, the OH group, no methyl group is attached to the carbon atom with the OH group. See, if we take this carbon atom, on this side it has this group, and on the other side it has no methyl group is attached here. Therefore, this is not considered as the major product. But if we consider the second case here, the OH group, where the carbon atom, these are carbon atom attached to the OH group. Considering this carbon atom, one methyl group is attached to this carbon atom. Therefore, this is considered as our major product, and then this major product undergoes reaction to give our, it undergoes tautomerization reaction to give our CH3, CH2, CH2, and then this would be form our, these alcohols would form our aldehydes, and then this would be our final product. And because this was our major product, because the carbon atom that was attached to the OH group has one methyl group. Therefore, considering the major product of this would be taken as the main major product to undergo the tautomerization reaction to give our aldehydes. We have one last topic remaining for this unit, that is the aromatic hydrocarbons. Therefore, I'll be discussing that in the next video.